Okay, adding and subtraction, so I should say subtracting, sorry. Subtracting fractions with the same denominator. So remember, the denominator is the word that we use to describe the bottom number of the fraction. So things with the same denominator are what we say they have a common denominator. So things like 1/4 and 3/4, they both have 4 on the bottom. So that's their common denominator. It's the same thing. So adding up fractions with common denominator is kind of the same because, or kind of easy, because you can imagine it's things like just having a circle and breaking it up into quarters. So there you've got 1, 2, 3 quarters in that pile, and another quarter in that pile. And if you add them all up, you've got 4 quarters total that you can put back together for a whole. So 3/4 plus 1/4 means that I've got 3/4 of a circle, 1, 2, 3 of them, and I've got one more quarter of a circle. So there's the other quarter of the circle. And if I add up the top, 3 and 1, that's a total of 4 that I have, but they're all still quarters. So the bottom doesn't change because I just have 4 quarters. And in this case, 4 divided by 1, you should think, oh, that gets me back to 1. But sometimes we've got examples that don't simplify back to 1. What if I cut up a pizza into fifths? And I had 2 pizzas, and I cut them up into fifths, and at the end of it I had 3/5 left over, and another 1/5 left over from the other pizza. So how many fifths total are left over? And again, it's that idea of if the denominators are the same, we're counting up the same part of an object. That's 3/5 plus 1/5 gives me a total of 4/5. I've got 4/5 total. And this is the same for subtraction. I could have something like 10/12, and I could take away 2 of those pieces of the 12ths, and that would give me, well, if I had 10 and I take 2 of them away, I'm now down to 8 of them, 8/12. So you add or subtract the tops, and the bottoms stay the same each time. Thinking about that as another example, if I just had a big pizza that I cut into 8 pieces, I'm starting with 8/8, and if I eat 5 of those pieces, so I'm going to chomp on them, 1, 2, 3, 4, 5 of them I chomp on, and those get eaten, I'm left with 3. And we can see that here as 8 from the 8 that I started with. I take away 5 of them, and I've now got 3/8 left. And keep in mind sometimes, generally it's a good idea to convert back to a mixed fraction. So if I had leftover pizzas that I'd cut up into 8ths, and I had 7/8 of one pizza, and 3/8 of another pizza, and one more 1/8 of the third pizza, now adding up 3 different piles. Here I've got 7, here I've got 3, and there I've got 1, so if I add all those up, I end up with 11/8 of the pizza. And you might notice that that's an improper fraction. So I'm hiding actually a kind of a whole pizza that I can reconstruct out of the 8 pieces that I've got. So if you want to think about it, I could take those 7 and that 1, if I add those back together, I get one whole pizza again, with 3/8 left over. So those can combine together to give me a whole, 8/8, and then I still have the 3/8 left. So that's 1 3/8. You can do that the other way, also trying to remember that you can do 8. How many times 8 goes into 11? And that just goes in once. And that takes me up to 8, and I need 3 more to get to the 11. So adding and subtracting fractions when you've got the same denominator, pretty straightforward. As long as the bottoms are the same, just add or subtract across the tops, even if it's more than one of them. Keep the bottom the same, and simplify if you get an improper fraction.